This lesson is going to focus on transportation and deposition of eroded material. We're going to be looking at the different types of transportation and the different things that cause deposition to happen in a coastal system. Oh, looking at this slide is like looking at an old friend, isn't it? Longshore drift. So this can also be called littoral movement in exams, so just be aware if the question talks about littoral movement, it's just talking about longshore drift. Okay, I'm sure you're all familiar with this. It's the classic example mentioned when you talk about spits, when you talk about case studies like Dawlish Warren. So this is all down to the prevailing wind. So the prevailing wind is the dominant wind direction in an area. When that is what we call oblique, which means it's not parallel, so it's not going the same way as the shoreline, and it's not perpendicular, so at a right angle to the shoreline, so it's just at an angle between 0 and 90 degrees to the shoreline, then what it will do is it will push the waves up the beach at an angle, as you can see in the diagram below. The backwash drags it back down the beach at a perpendicular angle, though, as you can see in the diagram, and you end up with this zigzaggy movement of material, which is going to move sediment in the direction of the prevailing wind. Offshore currents. Now, an offshore current is a current that moves away from the coastline, so its path goes offshore. And these can carry material out to sea, but they get weaker away from the shore, so this can lead to deposition out at sea in things called sandbars and sandbanks, usually in the eddies of rip currents, and eddies are just loops of swirling water. You can often see an eddy in a river. It's where there's like a little divot in the floor in the bed of the river, and the water is disturbed there, and what that will do is it will cause deposition, because basically the water is just staying in the same place. You can see a map of eddies on the top right. The photograph is all the swirling currents. Now, if you imagine if the water is just going round and round and round and round, it's not actually going anywhere, so the material it's carrying is just going to end up there. So you can end up with sandbars and sandbanks. Now, there's some good examples along the coast. In Bournemouth, there's a whole area called Sandbanks, which is formed by this. Some of the most expensive property in the country is found there, and even places like Dawlish Warren have got an offshore sandbank caused by this. So material taken out to sea, the current loses energy, and it deposits the material, forming things like sandbars. So the next four we're going to look at are four you'll be familiar with if you studied rivers or coasts at GCSE geography. Each of them depends on the size and weight of the material being carried, as well as how much water the energy's got. How much energy the water's got, excuse me. So the first one we're going to look at is called solution. Now, this is exactly the same as it is at GCSE. So this is where material is dissolved into the water by the water's chemical properties. This usually happens to calcium-based rock, so I've put chalk and limestone as an example there. And you can see on the picture on the right hand side you've got some calcium carbonate under a microscope, so they're tiny little particles. Solution isn't visible in the water, so if you go to the beach and it looks crystal clear, there will be material in solution dissolved in that. Ultimately though, what's going to happen to that material in solution is microscopic organisms are going to use that to build their shells, and once they die they'll collapse onto the sea floor and form sedimentary rock, or alternatively corals extract the calcium carbonate to make their structures. So once the material is dissolved, it's going to be deposited inside living things, and then ultimately that's going to turn into rock. It's actually part of the rock cycle. Okay, so that's solution. Hopefully that's no different to what you learned at GCSE. The second one is suspension. So this is where the water has enough energy, or the particles are small enough, or a combination of the two, to just hold the particles, and they're just carried there. It's suspended in the water column. So if you go to the beach and the water's cloudy, then it's going to have a lot of material in suspension. So sometimes the water will appear to be cloudy, or you could just see fine little particles in it. So for example, the picture on the right hand side there, you can see there's lots of little grains in suspension in the water. Okay, so these are small particles, doesn't require a lot of energy, so this is quite common. Right, the next two are often ones that get confused, so make sure you're really familiar with these. The third one is saltation. Now, this has nothing to do with salt. Okay, this is quite common one to come up in like a 4-mark introductory question. So like what explain the process of saltation, something like that. Now, saltation is where the pebbles bounce along the seabed. Now, this takes quite a bit of energy from the sea to be able to bounce these along. And if you think about it, the reason why they bounce and they're not carried in suspension is because of their size, or because the ocean hasn't got enough strength. So these pebbles, the ocean's got enough strength to pick them up, but not enough strength to carry them. So it can pick them up, then they start to fall back, they bounce, then they're picked up again and again and again, and that's how they move along. So this is saltation, where the particles bounce along the seabed, bounce, bounce, bounce. And the fourth one is traction. Now, this is reserved for the biggest rocks that require the most energy to move, and this usually only happens during a storm. So the most of the time, the rocks are too big, they just sit on the seabed doing nothing, because the sea's not got enough energy to move them. But obviously during a storm, there's a lot more energy added to the water, so suddenly the water can move these big stones, and they end up being rolled up the beach and rolled down the beach and rolled everywhere. So this is traction, and this is where the stones, large stones, are rolled by high energy. So you need big stones, big energy to move them. Okay. So this is a nice little diagram to illustrate this, and the process that happens at each one. Like I said before, make sure you're familiar with these, make sure you know these inside out so you can talk about them, because when it comes to your case studies of, well, why is this happening, rather than you saying, oh, material was transported, I want you to be able to look at the sediment and tell me what processes are happening. Is it saltation? Is it traction? Is it suspension? What's going on here? Okay, so make sure you're really familiar with these. Go over them if need be, make your flashcards if need be to help you out, but make sure you know these. And it's quite simple. The bigger the material, the more energy is required. Okay, so you've got your solution is your tiny dissolved ones, doesn't actually need any energy, just needs chemical reaction. Suspension needs the least energy because it's only carrying little tiny things. Saltation needs a bit more energy because it's got bounce, medium-sized sediment, and then traction needs the most energy because it can only roll big sediment. Okay. So now we've looked at transportation, we're going to look at deposition of that material. So we know the material gets moved around, we know it gets held by the water, but what causes it to be deposited? What causes it to leave the water and end up on land? Now, like it says here, it's all to do with stuff that make the water lose its energy. And eventually that sediment's going to end up on the seabed, be added to a depositional landform like a beach or a spit, or just added to the shoreline in things like estuaries and deltas. So have a quick think, jot down some ideas of what can cause the sea to lose its energy, and then see how many you've got right as we go through them. So take about 30 seconds, think in your head, what causes the sea to lose its energy? First cause of coastal deposition is a change in energy source. So this is dependent on where the main energy comes from, but essentially something changes and the amount of energy that the water has decreases. I've put a few examples on here so you can see an ocean current gets weakened, the prevailing wind changes direction, the tidal range changes, something like that. So something changes, there's less energy, so therefore the water has got less energy to carry sediment, so it deposits more of it. It's natural. Okay, the less energy you've got, the more deposition you're going to get. Okay, so something changes and the energy source isn't as strong as it used to be. The second cause of coastal deposition is a discontinuity in the flow of the water itself. So something slows the water down essentially and interrupts its flow. The picture on the left there, you can see you've got two different bodies of water meeting each other. They'll get in the way. They've got different densities, so the waters aren't actually mixing there, which is why you can see the really clear divide between the left-hand water and the right-hand water. Now, when one water body hits another body of water, they slow down, they deposit their material, they lose energy. Now this classically happens at the end of a spit. So if any of you have been to Dawlish Warren, you know you've got the River Exe there. When the River Exe hits the sea, it's going to lose its energy, which means the material and sediment it's carrying in both the river and the sea is going to be available for deposition, because basically the river hits the sea and slows down. So the flow of the river changes and it loses energy and slows down. Discontinuity in the flow. The third cause of coastal deposition is increased friction between the sea floor and the sea water, and obviously friction is going to slow things down, so therefore as the water gets slower it's going to have less energy and it's going to deposit more material. Now if you think about it, if you deposit more material, that's going to mean more material in contact with the seabed, which is then going to cause more friction. So this could be an example of a positive feedback loop where you get increased deposition actually causing more deposition. And if you think about things that are happening, it could be maybe some tectonic activity raises the seabed, means there's less water on top of it, which will increase friction. This is really for shallow seas, so shallow waters, because a higher percentage of the water is actually in contact with the seabed, so it's going to be more friction. Obviously the largest material gets deposited first, and that's why often we see larger material deposited at the base of beaches closer to the sea and smaller material at the top, unless it's just had a big storm, in which case it will all be mixed up and shuffled around. So yeah, more friction means more deposition. The fourth cause of coastal deposition is an increased load in the water. So something might happen and suddenly there might be a lot more sediment in the water, and the water just simply hasn't got the energy to carry it, so that's going to increase the amount of deposition you get. A good example you can see on the picture on the right hand side there, you might recognise that as Oddicombe Beach in Torquay. When that had that cliff fall, you can see the colour of the sediment, the colour of the water at the bottom is the same as the cliff, because basically all that sediment that was previously held in the cliff is now available to the seawater. The seawater is going to pick it up, but of course the seawater hasn't got that much energy, so it can't hold all of it. So all along that stretch of coastline you're going to get increased deposition, because that sediment is going to basically be put all over the coast by the sea. I don't know if any of you remember that happening. There was a house on the top that a woman had just bought in an auction. She'd never seen the house, but before she could get to it, it collapsed into the sea essentially. So that was bad luck for her. So it could happen from a flood, So for example, a river floods, it picks up loads of sediment, it carries that sediment down to the sea's like, whoa, you don't usually have this much sediment in you, and the river's like, yeah, sorry man, just had a flood. And then the sea's like, well, I can't cope with that, so I'm going to have to deposit it all over the coast, and then the coast ends up with more river sediment. Like we've just talked about, it could be a mass movement, dumping loads of sediment into the sea at once, or it could be a storm damaging things like a beach or dune systems. But basically you overload the sea and the sea can't cope with it, so it just deposits whatever material it's got. Increased load. And of course the load, when we're talking about water, is the amount of sediment it is carrying. So the load of a river is basically just all the sediment that's either in basically in suspension, solution, saltation or traction within that water itself. Okay, so that's the load, in case you were wondering. On this slide I've just put some recap questions. 4 of them are from the coast unit, so you should be able to get them. The 2 white ones are from changing places, just a little recap to get you thinking about that lovely subject. And the final 2 are from hazards, so have a go at them. You don't need to send me your answers for them, it's more of a recap activity for you. Okay, so yeah, just have a think, use your brain right now, stop the PowerPoint now, press pause, because this isn't the last slide, and just go through them, come up with, maybe it shouldn't be more than like 1 sentence for each one. Okay, so have a go at them, get your brain thinking. Right, this is the final slide, and it's a bit of an announcement really. So we've been asked, or I say we, all of the A-level teachers have been asked to give you some form of assessment before June the 26th. Now, the assessment is going to be based on stuff that you've done since you've been, well, basically broken up from college due to COVID. So what I'm going to do is on Monday the 22nd of June, I'm going to post the exam questions, and there's going to be a mixture of some multiple choice, some 4 mark, 6 mark, 9 mark and 1 20 marker. Okay, they're going to be based on hazards and coasts. Little tip for you, we've not done a coasts case study yet, so the 20 marker will be on hazards. Okay, as it says there, you can use your notes to help you if you want to. Okay, I'll leave that up to you, and I'll politely ask that you just put at the top of your exam if you used your notes or not. I don't mind if you want to, because obviously it's the end of the year, everyone wants to do well. It's going to be an hour and a half. Now, I can't obviously just set you a time, say, oh, everyone log on at 9:30, do it, and then hand it in to me at 11. I'm not going to do that. I'm literally going to post it on the Monday, and I want you to be mature and think, right, I'm going to set a timer for 90 minutes and I'm going to smash through this exam. Okay, and do it that way. You have the week to get it done, so if you think I've done half an hour, I'll come back to it, or I'm going to spend, I don't know, I'm going to spend 25 minutes on the 20 marker, have a break and come back to the rest of it another time. Again, that's up to you. Yeah, you're going to have the week to get it done, and it must be handed in by Friday the 26th of June. If it is not handed in by the end of the Friday 26th of June, you're basically going to get 0 in your end of year assessment. Okay, so it's a good opportunity for you to show me what you know. I know we've not done that many things for this, but that's why it's open book. I want you to do well, and obviously all of you to end the year on a really positive note. And yeah, so that's a lovely way to end this video. Okay, and yeah, thank you. Hope you enjoyed that transportation deposition and a lovely assessment announcement.